All right, for problem number 19, it says how many moles are in 40 grams of water, 245 grams of carbon dioxide, 138 grams, well, let me write this down. So they want to know the moles of 40 grams of water. Is that what they said, water? Let me write that a little better. 40 grams of water. 245 grams of, where's my spot here, of carbon dioxide. 138 grams of nitrogen. And 56 grams of O2 or oxygen. Okay, remember that the nitrogen and oxygen are diatomic gases. It means they like to travel in pairs. That's why we have O2 and N2, right? So those numbers that are in the back of the book. So for example, I said that oxygen, right, has a weight of 15.99. What they're saying, every one of these numbers here. So somebody pick out an atomic number.
1.
No, pick a random one between 1 and 100.
3.
No.
16.
No.
Okay, 70. 48.
Okay, all right, we'll do 70. So 70, oh no, not 70, that's a...
45.
Ha, you got excited.
77 is a great number. Right here, we have a molecular weight of 192. Now, what does that mean? Somebody tell me. Little chemistry review.
Hey, ciao.
What does that number mean?
Mass of the
So now to do this, it's 1 mole divided by the molecular weight, okay? And so in your textbook, if you look in the periodic table, you see that hydrogen is equal to 1 and that oxygen is equal to 16. It's like 15.99999, so you can round up to 16. So I have 2 hydrogen and 1 oxygen. So I have 16 plus 2. So now the way this works to find out how many moles, I have 40 grams of water. So 1 mole is equal to 18 grams based on the molecular weight. That's what remember that the molecular weight tells us how many grams 1 mole of that substance is. So when you look in the periodic table and the molecular weight, and when they say that it's 15.999, what they're really saying is if you take 1 mole of oxygen atoms and weigh them, it would weigh 15.99999 grams. So the conversion is always going to be that number in the back of your book with the periodic table per atom. So this is 1 plus 1 plus 16. When you plug that in your calculator, you should get like 2.2 moles. So this is 2.2, and we can abbreviate moles with MOL, right? I wrote it out the first time, but it really should be MO. Well, let me slide this over a little bit. Where did I put my marker? All right, because I'm kind of running out of room. So let me slide this over a little bit. Make a little room. Okay, so it's 2.2 moles, like that. Now, if we do the same thing for carbon dioxide, we have 245 grams, and then we just need to use the conversion factor of 1 mole over, well, we already know that oxygen is 16, right? So 16 is going to be, and I've got 2 of them. So 16 times 2 is 32. Plus carbon. Now what's carbon? Is that 12?
Yeah.
Is that what it was? 12. Hey, not too shabby, huh? So that's really 245 divided by, what is that, 44? So if I plug that in my calculator, I get 5.57, right? Moles. Okay, does that make sense? Now the same thing here, nitrogen has a weight of 14. So if I say 138 grams times 1 mole over, what did I say it was? 14, right? So it's 2, right? Because there's 2, so it's 28. It's not 14, it's 28. So I'm going to say 1 mole over 28 grams. Because it's a diatomic gas. So then 138 divided by 28 will yield 4.93 moles. And then for oxygen, we already know it says 56 grams. 1 mole of the diatomic molecule of O2 is 16 times 2, so we're going to divide by 32. If I plug that in the calculator, and maybe I'll just do one so you see where it's coming from, I'm going to end up with 56 divided by 32, and so I'll get 1.75 moles. Does that make sense to you guys?